Okay, so we have these three graphs. How are we going to sketch this information in three dimensions? Well, I'm going to start with the XY plane, and I'm going to sketch my graph of the ellipse. It comes out to 2/3 on the y-axis, so let's just put 2/3 here. So this would be the point 0, 2/3, 0, and this of course be 0, negative 2/3, 0, and I'm not going to label it because there's going to be enough stuff on the board to start with. And then at x we're going to have the point 1, 0, 0, and its opposite, negative 1, 0, 0. And I've already labeled something in the wrong place. Okay, so now here's the line where x equals 1. Here's the line where x equals negative 1. Here's the line where y equals 2/3. And here's the line, that was negative 2/3. And here's the line where y equals 2/3, right? And I'm not going to label those lines, but I will then sketch our rectangle. And now I can sketch the ellipse. It has to be tangent here, 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 and here. It has to be nice and smooth so we can do a pretty good job of sketching this ellipse. We come out here and we make kind of a big turn because of our orientation. And down here, kind of a similar thing, and out here. And we get I was just going to say a pretty good ellipse, but it's not that great. Okay? Right here's our ellipse in the XY plane, and we can see it's in the XY plane by these projection lines and so forth. Okay? Now we want to draw the intersection with the XZ plane. So what do? Well, we've got to come down here to, let's say this point is our vertex at 0, 0, negative 4. That's a common vertex to the parabola in the XZ plane and the parabola in the YZ plane, right? And, as it turns out, that 1, 0, 0 is still in a bad place. Total inability. You're observing a total inability to anticipate where things are going to go. Okay, well, we have this point, right? And we have this point and this point on our graph in the XZ plane because, of course, our intercepts with the x-axis are at negative 1, 0, and 1, 0, right? And that would correspond to negative 1, 0, 0, and 1, 0, 0. And there's implicitly our negative 1, 0, 0. Okay? And this is a parabola, meaning that it's got a horizontal tangent here, right? So if we want our tangent to be horizontal, or say horizontal, but you know, there are a lot of horizontals when we get into three dimensions. Anything in the XY plane is horizontal. The parabola is tangent to the a line parallel to the x-axis, right? So we draw our line parallel to the x-axis down here. So I'm going to draw just a line. Here's the direction of the x-axis. We just draw a little line segment parallel to the x-axis. Now we've got to go through this point, and come down and be tangent here, right? So here we go. We come down here, and we got to come around. We're tangent at this point, and maybe I kind of hit it. And it could look like this, okay? Does that make sense? Okay, so, and then it goes on up, because it's a parabola, it's getting pretty steep. So we have that much of the picture. And I didn't quite hit the point of tangency right, but close enough, and you can do better. Okay. Then we'll draw the parabola in the YZ plane. And that parabola is going to be tangent to a line parallel to the y-axis at its vertex. And the vertex, of course, is at this point. So we go ahead and just draw this little line here. But this one's going to be pretty easy because everything's oriented kind of the way you expect it to be. So we're going to draw a parabola that goes through this point and this point. Of course, you want to verify that when y equals 2/3, you get z equals 0, right? That's easy. If y is 2/3, y squared is 4/9. 9 times 4/9 is 4. 4 minus 4 is 0. So very simple calculation. So we didn't pick that up, you know, take that. So, you know, I kind of carelessly, I wish I hadn't extended these blue lines because they kind of look like they're going through these points on the way to these points. And I didn't choose my perspective as well as I might have. Well, I'm going to get a little sloppy here. Too bad, because it's going to be a really pretty picture, but I've got to mess around a little. Okay, so I'm going to just obliterate this much of the blue graph. And try to get rid of some of the smudges so it won't be as bad as it might be. Okay, so I've stopped the graph at the wrong point here. Should really go up to there. Okay, now if I draw the graph with vertex here and points here, it's very clear that it's going to look like this. Make sense? Now you got to understand that this is in the YZ plane and this is in the XZ plane. So to make that a little clearer, I've got to draw some projection lines from the y-axis down here. And I'm going to draw some projection lines from the x-axis down to the blue graph. And of course those lines are all smudged up so you probably can't see it. But that's where it is, okay? So we've got this much of a picture, and then we can extend this. This graph keeps getting steeper, and the orange graph here is narrower, for obvious reasons. It's stretchable. It's got a stretch of 9, whereas the other one has a stretch of 4. So it comes up kind of like this. This one comes up and eventually crosses this when it goes outside of the other. This one comes up, gets very steep. This one comes up and gets, well, stays less steep. It kind of stays, from our perspective, it looks like it stays outside of this curve, but these curves, remember, the orange curve is in this plane, the blue curve is in this plane, okay? Well, that's not a really extraordinarily clear graph. So we want to do a little more clarification. So I want to know, let's see, what's the intersection okay. What's our function f of x, y in the plane y equals, z equals 4. Work that out and sketch yourself just a two-dimensional graph of the function in the plane z equals 4.